Welcome to my talk, everybody. How to fail with JavaScript. I'm Nick Johnstone. I'm not going to introduce myself much because this talk is about me. Let's do it. So this is a story about learning. It's a story about failure. And really, it's just a story about a kid who wanted to make some games. This is me 10 years ago on my first day of high school. I went to a really strange high school in Christchurch. Oh no, and it broke. Went to a really strange high school in Christchurch called Unlimited Painga Tawhiti, which was very much about having a self-directed approach to learning, and you can see in this photo that I'm really excited about that. Being a strange high school, we called them learning advisors rather than teachers because everyone is a teacher, was really into documenting stuff. So we have this amazing video from my first term where I was making a game in GameMaker, and if I'm lucky, the sound will even work.
It'll come up with certain, and you'll get scores, and you'll get points for it.
Just this. I talked for like a minute and a half after that. I was wrong. Okay, I made a lot of games in high school. This is my old GameMaker games repository on GitHub. Most of this is just like an hour to an afternoon of work until I stopped. And the main reason for that is because I sucked so badly that I couldn't actually build anything without breaking everything that came before. That will be a theme in this talk. Just turns out that making games is really, really difficult. And if you haven't made a game before, this might be surprising because if you think about the sort of things that we use computers for, like the sort of problems we solve, like banking or city planning or logistics or running airlines, all of that stuff is like really complex and has really difficult problems in it. Game development is kind of strange in that almost every single part of it is really, really, really hard. For example, I imagine most of the people in this room are web developers or have worked with the web a lot. The vast majority of the code that you write probably doesn't matter how fast it runs. There's a lot of stuff where it does, but most of the time, we use like JavaScript and Ruby and languages like that. It's fine. We can pay a huge overhead on the code that we run. Turns out that game development, actually, you need to write really fast code, and it needs to simulate quite complex things interacting, and it's just kind of upsetting because if you think about it, like, the best game developers in the world are actually children. Like, if you look at children playing, they just come up with all of these amazing games just using like balls and using pen and paper or just like nothing. They're just amazing game developers. But when you actually try and like give a kid a computer to make a game, they're like, oh, cool. Okay, I have this idea for this thing and it's going to be amazing. And then you just cry. And I still just cry. And part of the reason for this is because game development requires a really strong background in both math and logic in a way that doesn't really make sense if you're just thinking about like the actual game part of games. Like, it's like, okay, if you want to be a programmer in web development, assuming you're not working in a very like financial field, you probably need to know some arithmetic and you need to know what a variable is. And that's about the extent of the math that you really absolutely need to know. If you want to be a game developer, if you want to make like a game that's like Doom, like 23 years old, whatever, arithmetic, algebra, trigonometry, calculus, physics, and then you also have to be John Carmack and come up with like crazy ways to optimize your programs. And it's just absurd. Like, in order to make simple games, you need about 10 years of rigorous study. And that's just absurd. So you probably think, like, what does any of this have to do with JavaScript? Well, fast forward, like, quite a way into the future. I made a lot of games in high school. I started working in tech. I came up to Wellington and did Dev Academy. I was in the first cohort like 4 years ago, something like that. And I learned about web development and Ruby on Rails and JavaScript. I don't know if this is true for everybody, but learning JavaScript was a really upsetting experience for me. I really distinctly remember that. But after I stopped crying, I was like, wow, the browser is this amazing tool for building applications, and I have like really high level primitives that I can use to make interesting stuff, and I can just share it with people. And it runs on my computer, and it runs on a phone, and it just runs everywhere. I'm like going from making stuff that just ran like was an exe on Windows or whatever, and like legitimately 50% of the world will just never play your game because they don't have an operating system that can run it. Like that's just silly. So I was like, I want to make games with JavaScript, and so I started doing that. I started making games with JavaScript, and I really quickly found out that it's a really bad idea. Like, if you want your games to run fast, it turns out that JavaScript has a memory management technique called automatic garbage collection, where you don't have to worry about like, hey, I want to allocate some memory and then later on I need to manually deallocate it. JavaScript just will occasionally pause your program, look at all of the values, and go, hey, you're not actually using this anymore. I'm going to clean this up. And in most web applications, that's just fine. It's like the best strategy ever. You really want that. But in games, because they need to run really smoothly, they need to generate like a new image 60 times a second. You have 16 milliseconds to do everything you need to do to produce a new frame. And sometimes garbage collection pauses your application for 100 milliseconds, and you just like get a hiccup in your game. And it's just really unpleasant. And I was also starting to think, like, what if we didn't have to write code to make games? I specifically came across a comment on the internet somewhere that was like, it made the very pithy observation that game development at a certain point is pretty much just like fiddling with numbers and negative signs and plus signs and how you mess with things until it just works the way that you want. And I was like, that's kind of a joke, but it is so true, actually, if you've actually done any game development. So much of it is just like fiddling with constants until it feels the way you want it to. And I realized that what you're really doing is you're searching for the right code. And you're doing it in a very gradual way. Like, unlike a lot of applications, a game that's like 90% correct is still really useful. You're like, oh, this is pretty good. Sometimes it doesn't do what I want, but it's pretty good. Compared to a bank where 90% is like, oh, I got fired today. Because you have a security hole or whatever, you know. It's really important to get the 100% functionality in web applications. That's a strange insight, but I started realizing, like, actually what I could do is I could make this game development tool that would let the user express the behavior of their game as a series of animations, and then it would use a genetic algorithm to search for the right code to power the game for that. So if you've never encountered genetic algorithms before, they are both a type of machine learning, but also really just a search technique. And if you think about search algorithms, pretty much you can always just start by brute forcing your search space. You can just try every possible combination until you find something that works. And the reason that you don't do that is because it takes an infinite amount of time, and that's not very good. So all search algorithms are just cutting down that amount of time from brute forcing. That's all that it is. And genetic algorithms are pretty much a way where you generate a random solution and you check how close is this to the actual outcome I want. And then you make a whole bunch of random solutions, and then you combine the ones that are closest to what you want. And you keep doing that, and you hopefully move towards the ideal outcome. I was like, that is pretty much the game development process. We're pretty much just genetic algorithms trying to make games. And so I was like, okay, cool. I'm going to make this in JavaScript. So welcome to Act 1, failing with Kiwi.js. Now, at this point, it was like May 2015. I had been programming JavaScript for maybe a year and a half, and I had seen someone at PowerShop, where I was working, give a talk about making games with Kiwi.js. So Kiwi.js is a little JavaScript library made by some people in Wellington, actually. I think Dan Millwood and co. over at Gamefruit. And I was like, oh, cool, this looks like a thing I could use to make this game development tool. And so I made a prototype. My first goal was to make Pong. And this is what the first incarnation of Helix Pi looks like. You can move stuff around and kind of plot out a different sort of path it should take and provide it with input over time as well, so that you're trying to teach the computer to understand, when I press the down key, this paddle should move down. When I press the up key, this paddle should move up. It's like, oh, cool, I can actually make this. It works, kind of. I gave a talk at PowerShop. I don't know, I'm not sure if anyone here went to that, but it was a while ago. It was like 3 years ago. And this is just coincidentally the thumbnail that YouTube pulled out of that entire video, which I really love, like including my expression. So it did work, kind of, but not quite. So how did I fail? The first case is really obviously, I failed at estimating complexity. When I started working on this project, I booked that dev talk for 3 months in the future. I was like, I'm gonna be able to make Mario by then. I'm gonna unveil my new programming paradigm from the world, and like everyone's gonna be like, that's awesome. I hadn't successfully made Pong after 3 months of like earnest work in my spare time. So yeah, and I remember talking to my coworker Kelly, and I was like 3 months in, I was like, I thought it'd be much further along by now. And she's like, don't worry, Nick, it could take like 3 years. Little did she know. The second thing I failed at was genetic algorithms. So actually getting a rudimentary genetic algorithm together is not the hardest thing in the world, but it's really important that it is correct. And the worst part about it, common to machine learning, if it's not correct, it still mostly works, but mostly isn't really good enough. And so the ways I specifically failed at implementing genetic algorithms in JavaScript pretty much came down to memory management once again. Turns out that, and I didn't really understand this at the time, that by default, most of the operations you perform in JavaScript change memory, it mutates it, right? And if you have a couple of different parts of your application sharing a data structure and then you mutate it, it's really easy to unintentionally cause your application to break in really subtle ways. And so unsurprisingly, when I actually implemented like genetic mutations, do you mind if we hold questions? When I actually implemented genetic mutations, it broke my program because I was subtly mutating objects. And it's really hard to track those bugs down, especially when it mostly works all the time. So that wasn't very good. The last thing I failed at was, and kind of unsurprisingly if you saw that screenshot before, I failed really hard at UI development. And I was surprised. I thought the hard part of this was going to be the genetic algorithm. And it turns out that was hard, but the really hard part was both designing and implementing a user interface that was sane, easy for other people to understand. And once again, back to that key theme, every time I added a new feature to that user interface, everything broke. And it was just awful. I just ground to a halt. I lost all my motivation to work on that UI. And so this was May 2015. First of all, this is not a knock on Kiwi.js in any way. Kiwi.js is a game development tool, and I was using it to build user interfaces. Dan Millwood and I actually had a conversation about this later where he was like, yeah, we had the same thing where we started building UIs with Kiwi.js, and then we realized that we should be using UI libraries to do that. I was like, should have thought of that. So the scene was still like May 2015, right? At the time, we had React. The dominant pattern for managing state in React was Flux. I don't know if any of y'all remember that. I looked at it and I was like, this is really complex and scary. I'm never going to be smart enough to understand this. It turns out it was just really complex and not a very good idea. Go figure. Angular 1 was also a thing, and I looked at it and I was like, oh yeah. Also, I think history backed me on that one. And so I was looking around, and then one day I saw an announcement of the release of a new JavaScript framework, something that we all get so excited about, I'm sure. And it was Cycle.js. Now, Cycle.js is not a framework that a lot of people have worked with. It's pretty niche. It's not backed by any huge companies, but it effectively has a very functional approach to building web applications, and that was something I was really interested in. So I was like, time to rewrite everything in Cycle.js. Act 2, failing with Cycle.js. Funny thing, I was looking for a framework, but it turns out that I found a family. I've been part of the Cycle.js community for like 3 years now, and some of the most lovely people I've ever worked with. Collaborated with people all across the world and traveled to spend time with them and built some like really meaningful friendships. And it was just, I just had to include the slide just because it's such a lovely photo, but yeah, I digress anyway. So the first thing I failed at with Cycle.js was I watched Dan Abramov's talk from React Europe 2015 where he unveiled Redux and he showed off some amazing developer tools that he'd built with it. He actually built Redux just for the sake of developer tools. So like Dan is a man after my heart. Um, and he was showing off hot reloading, where he could just change his code and it would update instantly, and time travel, where he could like rewind back in time and then fix bugs in the past. I was like, that is cool. I want that in the technologies that I work with. So I built a time traveling debugger for Cycle.js over the course of a weekend. And when I say built, I mean I hacked together this thing that let you kind of look into the past, but it really actually didn't work. And I also built some hot reloading tools that did actually kind of work and are relatively novel in the space. I'm still pretty happy with those. And it turned out that the community was interested enough that I ended up over in Europe for the inaugural CycleConf in 2016. Shout out to PowerShop me Flux for Flux me PowerShop for actually funding me to go over there because the community was too small to afford flights. Yeah, and that was a really cool experience. I also, wait, weren't we talking about making a game development tool with genetic algorithms? What has this got to do with anything? I failed really bad at staying on task. And I spent like a year just working on random Cycle.js applications and learning them and building dev tools and other libraries for the Cycle.js ecosystem because it was really small and really new. So there were lots of opportunities to just go like, someone had a good idea in React. I can build this in Cycle. And people will be like, that's cool. Good idea. Yeah. But I did eventually remember that Helix Pi existed, and I got back to it, and I built a new version of the Helix Pi editor in Cycle, and it was better. Like, it was much better experience than trying to build a UI in a game development framework. But I still actually had a bunch of problems. I started really running into some of the limitations of working with a language with dynamic types. So I ran into lots of runtime errors and my application would just break and I wouldn't be able to come back from that. I was using local storage for all of my data and it turns out that you want to change the structure of your data in local storage over time and it has no mechanism for that, and then you have to write really crazy code to handle like what version it might be in. You build your whole like migration framework and stuff on top of that. And just generally, like building really complex larger applications is hard when there are so many moving parts, and if anything goes wrong the whole thing comes crashing down. So kind of back to that same thing where like I would add more functionality and just break everything that I had. And you're like, oh, Nick, you should just be writing tests, right? I was like, oh, actually, that was my other thing. I got really into TypeScript as well, and that was a really great experience, actually. I could constrain my application to like a reasonable set of behaviors and cut out like a huge class of issues that I had been dealing with before. I really didn't like TypeScript before I started using it. I don't really know why. I think I kind of had a bit of an emotional aversion to Microsoft technology, and also, yeah, like I only really started doing it because the Cycle community started writing a lot of TypeScript, and I was like, I guess I have to go along for this ride. And now I love TypeScript. Like it's really good. If you're writing JavaScript and you haven't tried TypeScript or Flow, I highly recommend that you find someone who knows it and just like get them to walk you through some of it because it can really save you a lot of time. Undefined is not an error. Undefined is not a function. It's no longer an error that I see very often in my life. Just good. And yeah, of course, I was failing at writing tests. And part of the reason for this is that writing tests for interactive browser applications is really hard to do in a way that is cost effective. By that, I mean developer time to the actual reward that you get out of it. So, unsurprisingly, I built some more tools, and then I built a testing tool for Cycle.js that let you test your applications with asynchronous events, and it ran. Cycle is designed in such a way that effectively all of your dependencies are injected, and it's all kind of modeled using streams, which are it's kind of a talk in of itself, and I've given that talk before, but the kind of takeaway was that we were able to build testing tools that allowed you to test, hey, what happens when this sequence of events happens over time, and they could run really fast, and they would never fail, which is like they would never fail because of timing issues or because Selenium was in a bad mood or something like that. So that was really cool, and the Cycle community once again invited me over to CycleConf in 2017. This time they had enough money to pay for my flights. That was awesome. Yeah, but hang on. Wasn't I working on a genetic algorithm game development tool? I seem to recall something about that. So once again, I failed at staying on task. Another, like, effectively a year had passed that I had just invested into my tools. And I started to feel really guilty about this because literally the whole reason I got into Cycle.js in the first place was just so I could do Helix Pi. And like, what am I doing? So actually, I got back to it and I built another version of the Helix Pi editor. And this time, I could actually keep adding functionality to it and it wouldn't break because I had types and I had tests and I had just gotten way better. That was the thing that I underestimated, was that I felt like I wasn't making progress on my project, but actually all of the work that I was doing grew my skills as a developer and expanded my perspective on what was possible. And it turned out that when I came back to Helix Pi, that all of the work I had been doing was effectively preparation to build that. And it was a good feeling because I'd gone from being like, I just like wasted 2 years doing this other thing to realizing that it's pretty much impossible to waste any time if you're learning. It all paid off. Still, this kind of got to the point where I really, the UI was no longer the problem, and it was the correctness of the genetic algorithm that was the real rub. And I did what a lot of people do when you run into correctness issues, which is go to functional programming, go to immutability, try and cut out as many issues as possible. And the real problem with that is that games and genetic algorithms are relatively unique in the space of things you might want to use a web browser for, in that they both need to be correct and really, really, really fast. And if you want to use immutability in the browser, so for those who might not have encountered that term before, it effectively just means that rather than changing a piece of memory every time you want to perform an update, you just create a new piece of memory and kind of throw away the old one. Remember what I said earlier about garbage collection? It turns out that if you use immutability to make games and game development tools and genetic algorithms, you spend almost more time collecting garbage than you do actually processing your application. And it's actually unacceptable. Like, it's just not viable. And so I like rewrote Helix Pi so it was like fully immutable and fully functional with all of the new things that I had learned, and it was better. I got rid of all of my issues with mutability, but the performance was so bad that it just wasn't viable. And so I started going in and like hand tuning things to be mutable where I thought it would be safe, and I just kept running into the same bugs, and they were so hard to track down. Every time I introduced a new one, it would take me like days of development to find it, to the point where I just stopped. I just ground out. I couldn't do it anymore. I got distracted again as well. You might notice a theme. So Cycle.js has this really interesting concept where you can model your entire application as a graph of interconnected values, and that's kind of what that looks like. I actually made a library called StreamTree, which is a domain-specific language for JavaScript that lets you write Cycle.js applications using effectively an ASCII art syntax that expresses a flowchart of how state flows through your application. And this actually works. Like, it's written in JavaScript. It uses the template literal functionality that came in through ES6, and it kind of goes through that line by line and pulls the code out of there and then like evals it. But I used the VM module from Node because I'm not the worst person in the world. And I was like, this is really cool, but it's also potentially one of the worst things I've done in my entire life. And I was like, well, we have this visual dev tool for Cycle.js that lets you see your programs like this and see the values flowing through them. But what if I wanted to actually write programs like this? So I started building a visual editor for Cycle called Bonsai. And this is kind of what it looks like. I never really got that far with it though, because once I had kind of built a prototype, I showed it to the person who originally invented Cycle.js, Andre Stolt, and he was like, this is really cool, but if you really want this to be adopted by anyone, it's going to need to be able to like load in a textual code base and also let people edit it textually as well. Like, no one's just going to use a visual editor for code. And I'm like, yeah, that's fair. We have all of this tooling that we've built up over decades and decades of development. Can't just walk away from all of that. And so, I don't know how many of you know Steve Purcell, but he is a fantastic developer. I have had the pleasure of working with him in a couple of different roles, first at PowerShop and then more recently at Smart Cities. And he really loves functional programming, and he really loves Elm. So, welcome to Act 3, Failing with Elm. So, when I first started writing Helix Pi, Steve was like, hey, you should do this in Elm. And this was back in like the 0.16 days, we're up to 0.19 now. Just they're going, they're still going, I love it. I'd read like all of the documentation and I'm like, this is super cool. But once again, I was kind of emotionally averse to it for no particularly good reason. The main rationale I was able to conjure up, whether or not it's the truth, is that I wanted to use JavaScript in order to have the largest possible number of contributors. It turns out that I've had like 0 meaningful contributors to Helix Pi the whole time, so that argument just doesn't fly in hindsight. But anyway, yeah, at Smart Cities, where I was working previously, we wrote like a really, really big complex application in Elm, and it was a phenomenal experience. For those who haven't encountered it, Elm is a functional programming language for the browser that compiles to JavaScript. It offers a wonderfully simple model of web application development combined with a type checker that is kind of best in class for web applications. It cuts out a huge array of possible bugs and has beautiful error messages, and it really makes refactoring a breeze. Like, I kind of fell in love with web development all over again when I started writing a lot of Elm. But it doesn't solve the problem of immutability and garbage collection. It still has the same approach. Actually, it's good because you cannot really mutate data in Elm. You can only allocate new memory when you want to update stuff. And that's really nice, except for the fact that if you want to make games and you want to make genetic algorithms, you end up with the horrible garbage collection issue again. So I was like, I didn't actually really go that far down Helix Pi rewrite in Elm. I made a very simple application at one point where there was literally one div on screen and you could click and move it around, and every like 5 seconds it would hiccup because of garbage collection. And so I posted it in the Elm Slack and I'm like, hey, I'm a noob, I must not get this. How do I fix this? And they're like, oh, what computer are you using? And I'm like, a late model MacBook Pro? And they're like, yeah, don't know. I'm like, well, that's not good. If I'm going to use a programming language for a performance-sensitive project, I need to be able to actually optimize it. Like, that's a really important thing. And the Elm community as well kind of has this idea that like the core team is really responsible for how the project works, and you can't really like it's not as easy to have a say in that project as it necessarily is for other projects. They have really good reasons for that, but it just kind of meant that Elm wasn't necessarily a viable option for me. Yeah, for the failing at memory management reasons, effectively. And around this time, Rust had come onto the scene, and so had WebAssembly. So if you haven't encountered Rust, it is a programming language that was developed by someone from Mozilla with the financial support of Mozilla, and it is kind of described as a systems programming language with a really high. It focuses on safety and performance, which it turns out were those things that I needed in order to make games and make genetic algorithms. And Rust, we're starting to get to the point where we can actually build Rust applications for the web, because there's this fantastic new thing called WebAssembly. And if you haven't encountered WebAssembly, pretty much the way I heard it best described is that when you write JavaScript, it gets taken in by the browser, and then it actually needs to be translated into a lower level set of instructions so that it can be executed by your CPU. And there's actually like an intermediate level of instructions in the browser, and it's different for all the different browsers. They all have their own virtual machine. And so all of the browser manufacturers got together, and by that I mean the ones that really matter, and they agreed upon a common subset of the bytecode in their virtual machines, and then they just exposed it directly. And that's WebAssembly. Yay. The best part about this is that it doesn't come with garbage collection built in. We've finally escaped the stop the world, freeze your application garbage collection strategy from JavaScript, which is kind of a trade-off because it means you can't just use JavaScript objects in your WebAssembly and vice versa. They're going to fix that. I hope they don't. Personally, no, I'm kidding, but you know, like, it's not my agenda. But the problem was Steve Purcell had made me fall in love with functional programming. I'd pretty much just been writing Elm and just been writing Haskell, and the days when I had to write JavaScript were the really sad days. I don't mean that as a knock on JavaScript. It's that whole thing again of just trying to avoid large classes of problems that you're not actually trying to solve. And it just for me, functional programming allowed me to build more complex and interesting applications without running into really awful problems with memory management and all that stuff. So I was like, Rust, really cool, but I actually want to use a functional language and I want it to embrace immutability first. And the thing that really stood out to me about Rust is that they have this really smart idea where Rust doesn't have a garbage collection strategy like most languages. What it does is the compiler will look at your code, figure out how the variables are used, and then as much as possible, it will automatically insert instructions to deallocate memory at appropriate points, which means that you get all of the performance of like highly optimized C code, but without having to actually do a lot of manual memory management. And you can actually employ that tactic in the browser thanks to WebAssembly. When you do need to allocate something on the heap, so when you need to keep something around longer than just like a function call, Rust uses a reference counting strategy. And if you haven't encountered reference counting, it's pretty much you have a map of all of the values that exist in your program, and you just keep track of how many times they're referenced. And when you make a new variable, put it in the map. When you reference it from somewhere else, you add 1 to that count, and when it gets down to 0, you just get rid of it. It's a super simple approach to memory management. And one day I was just thinking about it, and I'm like, most of the time in game development, you only ever have like one reference to a piece of data. Like the way game development normally works is you have like a loop and you have a state, and you update that every loop, but you generally only have like one reference to your piece of state. And in a functional language, if everything is immutable and you only have one reference to something, you can actually just replace it. You don't need to make a new copy of it. And I was like, wow. So hang on, we can make a functional programming language that uses pretty much the same memory management strategies as Rust, but can have all the guarantees of immutability without needing to actually allocate new memory all the time. Like 90% of the time, you can just replace memory in place. And this is not a new idea. If you just go on Wikipedia and look at the reference counting page, it just like really casually mentions this. But like no mainstream programming languages really embrace this. It's really crazy. Some of the more esoteric functional programming languages like Haskell are just getting into this with the notion, if you want to look into it more, the academic-y, mathsy background is called linear types, and it's effectively just a guarantee that a value will only be used like once. But you can just kind of employ it in a more simplistic way. I don't have a strong academic background, so I kind of look at a lot of their papers and I go, yes, quite understand some of these words. So I was like, what if I just write my own programming language that's like Elm, but has the garbage collection strategy of Rust and compiles to WebAssembly, because WebAssembly allows us to write really fast applications. Welcome to Forest. Forest is my programming language. So I started working on Forest November 12th last year, so it is just under a year old. The compiler is written in Haskell, and it's been coming along pretty nicely. The first thing, though, that I really failed at, I always have this thing. I'm a programming language nerd, and so I read a lot about programming languages, and there's like a billion of them in the world. There's like 10 that people use, but there's like a billion of them. And I'll often come across a new language, and I'll be reading the list of features, and I'm like, oh, this sounds really, really, really good. And then I see like an example of the syntax, and I just recoil in horror, because it's just like developers all have their own personal preference for what code should look like, and the worst possible case of that is when someone writes a programming language, because they're like, all the existing syntaxes suck. I'm just going to make my own one, and it's going to be great. And I even saw a quote from Richard Feynman the other day, the famous scientist, talking about how, like, when he was learning mathematics, a lot of the notation just didn't make sense to him, so he just invented his own notation. He was like, this makes so much more sense. And then he tried to teach someone else a problem. They're like, what are you talking about? What symbols are you using? And he was like, I should probably use the common notation that everybody else in the world uses. But when you're writing a programming language, it's really hard to pick a syntax, because like most people have worked predominantly with one family of languages. Like most people have worked with languages that are like C and have like curly braces or do end blocks and execute line at a time and have a whole bunch of conventions for how syntax looks. And then there's like functional programming languages which look totally different. And I know people who like hate functional programming syntaxes, like will just not use them just because they don't like the way they look. And I know people who like look at Ruby and JavaScript and they're just like, oh, like the syntax is so bad. And I think all of these people have fair points, but really what they don't understand is that syntax is primarily familiarity. Like it's just what you know, and once you get accustomed to something, you can just work with it fine. But syntax was like the least interesting thing to me. I just didn't think it was an argument worth having, and especially when I looked at like a lot of the conversations we were having in the JavaScript community, like React and Elm and Cycle all have different styles for how you express HTML and JavaScript. Like there's like React's JSX, which like hands up if you love JSX. Hands up if you really don't love JSX. Anybody? Okay. And then there's also like a more functional style, and if you've ever seen Elm's approach to writing HTML, there are lots of square brackets and commas in weird places, and you look at it and just like, oh, you really want me to do that? And especially it loses like one of JSX's main selling points, which is it looks like HTML, which I also think is a huge trade-off. But anyway, we're just having all of these arguments about like how that should look, and I'm like, this is one of the least important things I've ever heard discussed in my life, along with like semicolons or not, and tabs versus spaces, and like single quotes versus double quotes, and like all of the stuff that when I first started programming, I thought those were jokes. I thought that like tabs versus spaces, how could people spend time talking about that? And we still do. Like if you go on Hacker News, don't go on Hacker News, but if you go on Hacker News, there are people arguing about it. And it's like, why? There's so many more important problems in the world, like how to get rid of Bitcoin. No, I'm just kidding. Anyway, so I decided, I was also thinking about the visual editor and the whole problem that Stoltz had described to me of like, hey, it needs to be both a textual syntax and a visual syntax. And I don't know if you've encountered Lunalang, which is a language that came out like between me starting to work on this visual editor and now. And it has a hybrid textual and visual interface, and you can also kind of look at things like graphs. But they still had the same problem where they had to like pick a syntax, and I just didn't want to do that. So what I decided to do was not pick a syntax. And one of the most controversial points about Forest is actually that every developer can use their own preferred syntax. Syntaxes are just userland packages you can install. And there's like immediately like 1,000 objections that people have. They're like, but doesn't that mean that we just have to collectively agree on a syntax to use in our project? It's like, no. You have a virtual file system that you interact with that takes the code that's on disk and shows it to you in your preferred syntax and lets you edit it like that. It's great, right? It just works with all the editors in the world because it uses a tool called Fuse, which is file systems in user space. So you don't need to install an editor plugin or anything. You just open it with your editor, and it also means you get like live reload effectively, like when actually don't worry about it. As well as that, Forest also, I guess, it's still coming along. Like, I'll get back to, I got a little distracted on the syntax. Other problems that people generally get stuck down with are like, what about Git? Like, you can actually just teach Git to run your diffs and everything through a different pager, so you can actually just project them into the syntax that you want. Have to do the same thing for GitHub and Stack Overflow, and it does have problems like there's not going to be an official syntax. So if you come across a code snippet online, this isn't implemented yet, but I'm planning on having browser extensions that just translate it into your preferred syntax. But part of what this means is that we can actually build visual editors that have the exact same level of functionality as textual editors, and it doesn't matter whether or not your coworker likes to use like a weird Haskell-style syntax with like Unicode, Greek alphabet generics, and you just want to like write something that looks like Python or JavaScript, or use a visual editor. Like it's all just fine. And it means I don't have to argue with anyone about what the syntax looks like. You can all just argue amongst yourselves. Yeah. So where is Forest today? Forest is coming along pretty nicely. It actually has one syntax implemented right now, which looks like Haskell. And the reason for that is I don't want to make a bunch of syntaxes while I'm still figuring out the structure of the language and having to keep re-implementing them. It has a compiler and a type checker. Type checker mostly works, which is quite nice. I'm working on that at the moment. It was really amazing to learn that type checkers are not as magic as I thought. It turns out that it's pretty much Sudoku. Like, you just have a bunch of different constraints, and sometimes you have enough information to fill in a blank, and sometimes you don't. But the good thing is, like, unlike Sudoku, if you run into the point where it's ambiguous, you just tell the user, hey, put some stuff in here. You don't have to actually, like, figure it out. And no one ever explained that to me. Like, if you go on the Wikipedia page for the type system Haskell uses, the Henley-Milner, I'm actually just going to bring it up. It's too good to miss. This is the sort of experience you have when you're like, I really want to implement a type checker. And they're like, it's easy. You just got to do this. Hang on. Yeah, algorithm W, you know? Of course, with all of my academic background. And my favorite part of this as well is that it has side effects like this. Like, they're like, this is not actual math. This is math with side effects as well. You're kidding. I don't even understand the math involved here, let alone the side effects. But the frustrating thing is that it's not actually this scary if I've just been doing test-driven development. Like, it's like, this should pass, this should fail. What do I have to do to make that work? And I've been able to make a type checker that works relatively well, just kind of by taking it one step at a time and ignoring everything like this. And every time someone sends me a paper and they're like, yeah, just look at this crazy paper on proof trees, and I put it in a list. And I'm like, I'll get back to that when I understand what on earth you're talking about. So Forest also has code generation for WebAssembly that is sufficient to implement like Fibonacci and programs like that. So it has functions, and it has strings, and it has numbers, and it has case expressions, it has data types that you can unpack, and lots of functionality that you've kind of just come to expect in programming languages. There's still a long way to go before it is something really useful for people, and I really need to develop like a larger community around it to actually help me along the way, because it's like a decades-long sort of task to build a programming language. But that's fine. Once I get like a version 1 sort of going and anybody starts using it, if they do, you know, it'll be much easier to actually get contributors. Kind of the goal that I'm working towards right now is getting Forest to the point where it supports enough functionality that I can re-implement Forest in Forest, which is actually how like most compiler development works. You write it in like one language, and then once it's good enough, you write it in itself, and then you use the old version to compile your new one that's written in itself, and then you get a binary that you can use to then compile more into the future. And that's how, yeah, pretty much like it is the proof that a programming language is actually useful, is that it can implement itself, which is a very tautological perspective on usefulness that I feel only programmers really appreciate. Getting quite close, actually. Look forward to that. Anyway, wasn't I implementing like a genetic algorithm game development tool? I kind of forgot about that. So the whole reason I'm actually doing this is so that I can implement Helix Pi. And that's just absurd, right? But this is the thing. I'm a little ahead of the times in some ways. I have a really weird set of problems, and it turns out that a bunch of technology to make this possible has only really become available in the last couple of years. We're still really new at this web development thing as a community, and that's really exciting. It's like a great time to be a web developer. Yeah, I really want to finish Helix Pi in my lifetime. It's like a goal. 3 years. I remember when Kelly said 3 years, and I'm like, 3 years, okay. We're like, yeah, it's past 3 years now, and I'm working on a programming language. So, Epilogue. How is it a good thing that I just keep getting distracted? Like, how can I possibly advocate this style of development? It's just a joke, right? But it comes back to that same thing with Cycle.js. I spent like 2 years just working on Cycle.js, not working on Helix Pi, and feeling guilty about that. I was like, this isn't moving towards what I'm trying to achieve. But when I realized that the more I learn about programming and the more I understand, the easier it is to solve really complex problems, like no matter what they are. And so I've just gotten more comfortable following the route where it takes me. And I know if I just wanted to like ship some value, if I was a business, this would be the most irrational thing to do. And I should have just like kept plugging away at the JavaScript version until it was done. But to be honest, like I want to have fun while I'm doing this. And there was so much of that process that wasn't fun. So really, I guess my point is that sometimes it's really not obvious how to get from A to B. And sometimes it's not obvious that you're actually moving towards success at all. But it's often only with the power of hindsight that you can look back and go, I learned so much that enabled me to solve these problems. And I never would have guessed that this was the route that I needed to take. Really, my point is just keep failing. Just keep trying stuff that might not be possible, and just fail a lot and revel in that. Like it's if you're not failing, if you can't think of the times recently when you failed really hard, you're in your comfort zone. You've got to get out. You've got to try harder things, and you've got to just make horrible mistakes, because that is the only way you really grow as a person. And that's not just software. That's everything in life. Thanks for listening. That's me on Twitter. Questions?
Why do you call it Helix Pi?
I called it Helix Pi. Actually, a friend of mine came up with that name. We were trying to think of things, we were brainstorming, and I had recently learned there's this like music creation tool that someone built in Ruby, Sam Aaron, called Sonic Pi, and it's like designed for kids to make music with code, and it's named after, it has the same name as like the Raspberry Pi in terms of the suffix, and it's weird because it's contorted over time, but the Raspberry Pi was named that because of Python, right? And then Sonic Pi was named that because it turns out that what the Raspberry Pi did was it made it possible for a group of people to solve a set of problems that they weren't able to solve before. And that's what Sonic Pi did as well. And so Helix Pi as well is trying to enable people who don't have the background in code or mathematics or logic to make games, be the, like if they're young or if they aren't necessarily technical by nature. So I'm just kind of trying to push that Pi suffix as something that allows people to solve problems that they couldn't solve before.
Why is it called Forest?
It's called Forest because I was working on Elm, and I was like, I kind of want Elm, but I want there to be like many different types of trees. Like Elm is it's quite a homogeneous by design, whereas Forest kind of goes the exact opposite way. It's like, this is going to be a research language. You can all pick your own syntax. I want it to be something you can really easily hack on. The community can grow. So yeah, it's a place of many trees. It's also just a great name for puns. Like, I can't see the forest for the trees. Yeah, it's great.
Do you feel like the syntax for Forest will eventually converge on what everyone would want to be using eventually, or do you see it as maybe like 2 or 3 main ways, or how do you envisage that?
By nature of the way the tools are designed, there shouldn't be any reason that you have to converge. Like, I want it to just be as easy as possible to, like, I imagine you'd pull in something, kind of have like a command line tool that would be like, hey, what programming languages are you familiar with? Okay, you should probably start with this one, and then you should be able to customize it as well, like in the ways that you want. I also want people to be able to experiment with different types of syntax. I've also kind of made a promise that because it relies on a lot of, I'm betting really hard on this approach, and it actually requires me to prove that syntaxes can be like that for any arbitrary Forest module, that you can print it out to text and then you can parse it back and get the same code that you started with. And I have ways of testing that right now, but I am actually going to need to be able to automatically prove that for all syntaxes in order for it to work, and that is not yet done. So if I am not able to do that, I am going to pick a syntax, and that's just going to be it. So if it turns out there's any horrible problems with this approach, I'm just going to drop that entire part of the project, and we're just going to have one syntax. A lot of people have pushed me really hard to have like an official syntax for the sake of like code snippets on the internet if you don't have an extension, or like one person who was like, what if I want to print out my code? Like, if only we had something that was like paper, except it could change like dynamically. Like if anyone thinks of that, like let me know. Yeah, my hope is that we never converge. My hope is that we just keep expanding out.
Do you go straight into WASM or do you go into like LLVM, your compiler?
Yeah, so it's another question I get a lot. I actually go straight to WebAssembly, and there's a couple of reasons for that. This might also fall into the like emotional rather than rational in a lot of ways. Quick definition if no one's encountered it. LLVM is a compiler toolchain that Apple developed, and pretty much it's not like a programming language that an end user would use, but lots of programming languages compile to LLVM, and then LLVM can compile to like all the platforms in the world, including WebAssembly. And the reason that it makes total sense to make Forest compile to LLVM, because then it would run on native and it would run in WebAssembly and I wouldn't have to do a lot of work. First of all, this is a learning project, so I wanted to learn about WebAssembly. So that was kind of the first reason I started directly compiling to WebAssembly. The second is that I'm actually making another bet here, which is that WebAssembly is really weird, because if you've encountered any like low-level assembly code, it's very much like, put this number in that register, add these numbers together, do this stuff. WebAssembly is way higher level than that. It's like, it's quite similar to JavaScript in a lot of ways. Like it's kind of halfway between assembly and JavaScript. And so if you compile through LLVM, like from Forest to LLVM back up to WebAssembly, you're actually going from a high-level language to a low-level language to quite a high-level language. And so a lot of the optimizations that LLVM does end up generating like a lot of WebAssembly code. So I'm actually betting that if you want the fastest and smallest code, that it's better to handcraft a WebAssembly compiler, or to go through, there's another intermediary technology called binary N that is like something you can compile to LLVM, to binary N, to WebAssembly, or you can just go straight to binary N. I'll probably end up doing that. The other reason is that I want Forest to be able to run, like the compiler to run in a web browser, so that we can translate all of the different syntaxes in the web browser and have like a nice REPL and all of that interactive stuff. And if you need the LLVM toolchain in there, if you like install LLVM and the WebAssembly and script and stuff right now, it is 900 megabytes. So Forest is like, like 30, 40 kilobytes, like the compiler. So yeah. It's a lot of people have once again pushed me really hard to go through LLVM, but I am betting that it's going to be a better outcome to go for WebAssembly. And also, there's nothing to stop us from building an LLVM target down the road as well. Yeah, kind of the same thing. Oh, actually, I think it's way better, rather than going LLVM to WebAssembly, to go WebAssembly to LLVM. And actually someone, literally in the last 2 weeks, someone made a WebAssembly decompiler. It takes WebAssembly and it turns it into C code. So because WebAssembly is higher level than LLVM and assembly, and it's actually a really easy compile target when compared to some of the lower level ones. I think that the whole ecosystem will benefit a lot more if a lot of us just like target WebAssembly and then we build tools to take WebAssembly and turn it into native code. So something that's going to happen in the next couple of years, any of you can get famous in this room by doing what I'm about to say. In the same way that Node is literally just a virtual machine and some asynchronous I/O libraries that call like the system calls, if somebody makes something that takes a blob of WebAssembly and compiles it to native code and hooks it up so you can make some system calls, like that is going to be a huge deal. And if you've watched Gary Bernhardt's talk, The Birth and Death of JavaScript. If you haven't, I highly recommend it. He kind of has this fictitious prediction that we're all pretty much just going to end up running all of our code inside of web virtual machines by like 2040, and we're on that road, and I'm guilty of carrying us a few steps further down there.
Do you have any extension on Microsoft version or Sublime so people can write a code easier?
Sorry? The extension?
Yeah.
No, I haven't really started to work on a lot of that ecosystem stuff yet, because I don't actually have multiple syntaxes yet. Like all of the technology is there, and actually Raquel a while ago started working on a printer for the JavaScript syntax, which works. So once the language kind of stabilizes a bit, then I'll start building a lot of the tools around that stuff. But also, if somebody wants to help, like there are lots of opportunities for self-contained work streams that would be really valuable. I'm really focused on the type checker and the code generation right now because it's the really critical bit for the language. So yeah, not yet, sorry.
So the concept is based on the TypeScript and JavaScript, right?
Way closer to functional programming languages like Elm and Haskell. JavaScript and TypeScript, you can still mutate all of your variables, and you can cause side effects whenever you want. Whereas in Forest and Elm and Haskell, you can never mutate anything, and all of your side effects are represented as values that get returned from functions and then get executed sort of by the runtime, which means that you can't just like randomly log out to the console in the middle of your programs, which is kind of annoying. Or you actually can in Elm, but it means you have to think a lot more carefully around how do different parts of my programs compose together and how do the effects get sequenced and all that stuff, which is like an overhead when you start working with it, but can also be really useful and powerful in its own right.
So what is the current engine right now?
Pardon?
What is the current engine? The current engine to compile the language?
So currently the Forest compiler is written in Haskell, which is like, it's written in a subset of Haskell that is close enough to Forest that it should be really easy to port it over when the time comes. And actually, the syntax I'm using, I literally just copied most of Elm's standard library into my samples directory the other day and compiled it. So like I just stole most of Elm's data types because why wouldn't I, you know? And interestingly as well, if you can make, there's kind of this interesting idea that like a syntax is the ability to take some text and turn it into some abstract code and also turn it back to some text. But if you think about the compile target, like WebAssembly, you take the abstract code and you turn it into text, which is just like half of a syntax. And also, you could arguably write a subset of JavaScript and TypeScript, really just TypeScript, and then import that into Forest. So you could write a one-way translation from TypeScript to Forest. And as long as it was sufficiently constrained, you would actually be able to just pull it right in. Wasn't your question, it's just interesting. Any last questions?
How far did you get with Paul? Do you have like
No. I got to the point where I could make a paddle that moved up and down, and like a ball that like moved over and hit it, and like bounced back. That was like, which it turns out is like most of Pong. But then actually getting I had the same issue in that because the genetic algorithm was always slightly incorrect and it would often like mutate old versions of the code, it had the same problem that like 12-year-old Nick did, where every time I tried to add more complex functionality, everything would just break. And that's part of the reason why I went down this whole immutability, functional programming, safety route. Any last questions? All right. Thanks so much.